The Taj Mahal sits on a riverbank that floods every year. It has been there for 370 years. In that time, it has not settled. Not 1 millimeter of differential settlement has been measured between the north and south foundations. Not one crack has opened in the marble platform from uneven load distribution. For a structure of this mass, on this soil, subject to this hydrology, that is not impressive engineering. That is a violation of soil mechanics. This is an engineering investigation into a foundation system that should not be stable, a geotechnical survey that was classified the moment it was completed, and a construction timeline that cannot account for the technology beneath the marble. We are going to answer one practical question and leave one structural question open. The practical question: where did 20,000 builders live during monsoons? The structural question: who built the foundation and when? The textbook version is clean. Shah Jahan commissioned the Taj Mahal in 1632 as a tomb for his wife Mumtaz Mahal. Construction lasted 21 years, finishing in 1653. 20,000 artisans and laborers worked on the site. The upper structure is white marble, inlaid with semi-precious stones in floral patterns, using a technique called pietra dura. The documentation for this phase is thorough. Mughal administrative records list the cost of lapis lazuli from Afghanistan, turquoise from Tibet, jade from China. They record payments to calligraphers, stone carvers, and inlay specialists. The marble work is not mysterious. It is precisely dated, precisely costed, and consistent with known Mughal craftsmanship of that period. That is the official record. It is the upper structure. Now apply the same expectation of documentation to the foundation. The Taj Mahal weighs approximately 70,000 tons. It sits on the southern bank of the Yamuna River, a location subject to annual monsoon flooding. The soil is alluvial, soft. The water table fluctuates seasonally by several meters. Every structural engineering textbook will tell you the same thing. A load of this magnitude on soil of this type will produce settlement. Differential settlement is the term. It means the structure sinks unevenly because the soil beneath it compresses at different rates, depending on load distribution and moisture content. Differential settlement produces cracks. It tilts minarets. It opens gaps in masonry. The Taj Mahal has been measured by the Archaeological Survey of India, by independent structural engineers, by satellite imaging analysis, and by ground-penetrating radar. The result is consistent: zero differential settlement. The structure has not moved. For 370 years, through monsoon cycles that submerged the surrounding land, through earthquakes that damaged other Mughal structures in the region, through the groundwater extraction that has destabilized newer buildings in Agra, the Taj Mahal has remained level to a tolerance that modern construction on similar sites cannot match. That is the first impossibility. It is not a mystery, it is a measurement. The explanation is in the foundation, but the foundation is not documented. What is known comes from indirect observation, from construction records of nearby structures, and from one survey conducted in 1978 that has never been published. The foundation system uses interlocking ebony wood piles driven deep into the riverbank. Ebony is dense. It does not rot in water. In fact, it hardens. When submerged, ebony absorbs water and undergoes a mineralization process that increases its compressive strength over time. The wood becomes stone-like. This is not folklore. It is material science. The Taj Foundation uses the water table as a structural element. The piles remain submerged year-round. The seasonal fluctuation of the Yamuna River keeps them saturated. The load of the structure is transferred through the piles into a deeper, more stable soil layer beneath the alluvial surface. The system works because it is always wet. If the river were to dry up, if the water table were to drop permanently, the ebony would dry out, crack, and lose its load-bearing capacity. The structure would settle. The foundation is hydraulic. It requires the river. This is advanced hydroengineering. It implies an understanding of groundwater behavior, of material properties under saturation, and of long-term environmental stability. The design assumes that the river will always flow, that the monsoon will always return, that the water table will remain constant across centuries. That assumption has held. But the knowledge required to make that assumption with confidence, to stake a 70,000-ton structure on it, is not documented in any prior Mughal project. The Taj Mahal is not the first Mughal structure on a riverbank. Agra Fort sits on the Yamuna. Fatehpur Sikri, though not on a river, was built on similarly unstable ground and had to be abandoned within 15 years due to water supply issues and foundation problems. Humayun's tomb in Delhi uses a raised platform but shows measurable settlement. The engineering solution used at the Taj Mahal, the specific choice of ebony piles in an interlocking grid submerged in a controlled water table, appears in no other Mughal construction record. It was not used before, it was not used after. It has no documented prototype and no descendant. One structure, one use. No engineering tradition around it. The Taj Mahal has two construction layers. The upper layer is marble, precisely dated to 1632 through 1653. The lower layer is a foundation system with no date, no recorded engineer, and no administrative record of its design or installation. One building, two technologies, one thoroughly documented, one invisible in the archive. In 1978, the Archaeological Survey of India conducted a full foundation depth survey using core samples and ground-penetrating sonar. The survey measured the depth of the ebony piles, the composition of the soil layers beneath them, and the total depth of the load-bearing system. The results were classified immediately. The official reason given was sensitivity of findings. Sensitivity is not a technical term. It is an administrative term. It means the data, if released, would require explanation that the institution is not prepared to provide. The survey has not been published. The raw data has not been released under any Freedom of Information request. Independent researchers have been denied access. The Archaeological Survey of India has controlled access to the Taj Mahal substructure for 47 years, not because the data is lost, because it is sealed. What does that survey show? The depth of the piles is one answer. If the piles extend deeper than the construction timeline allows, if they reach a soil layer that requires drilling technology not available in the 16th century, that is a timeline problem. The composition of the wood is another. If the ebony shows mineralization patterns consistent with centuries of submersion before the marble was laid, that is a sequence problem. The survey would also show whether the foundation and the upper structure are bonded as a single construction event, or whether the marble platform was built on top of a pre-existing base. That is a question of contact layer analysis, standard geotechnical procedure. The data exists. It is not ambiguous. It is classified. Compare the Taj Foundation to a modern equivalent. The Lotus Temple in Delhi, completed in 1986, sits on similar soil. It required deep-driven concrete piles, continuous monitoring, and active ground stabilization. It has experienced measurable settlement. The Akshardham Temple, completed in 2005, used advanced geotechnical engineering, including soil replacement and controlled compaction. It is monitored annually for movement. Both structures were built with modern materials, modern equipment, and modern site analysis. Both show settlement within the expected range for their load and soil type. The Taj Mahal shows none. Its performance exceeds modern capability without modern technology. That is not a miracle. It is a performance gap. The Taj Mahal has sealed basement chambers near the river. They are not open to the public. They are not included in any official tour. Restoration teams access them under controlled conditions. Photographers are not permitted. Independent structural engineers are not granted entry. The chambers exist. They are maintained. They are not available for investigation. The Yamuna River has been hydrologically surveyed. Flood records go back 200 years. The monsoon cycle is consistent. Every year, the river rises. Every year, the surrounding land floods. Every year, the water table climbs and then recedes. The Taj Mahal sits in the middle of that cycle. Its foundation depends on it. The structure should require constant maintenance to manage the hydraulic pressure, to address erosion, to counteract the seasonal load shift. No such maintenance is documented. The structure is stable without intervention. If Mughal engineers in the 16th century solved the problem of building a stable 70,000-ton structure on a monsoon flood riverbank using a woodpile foundation system that strengthens when wet, why is that solution not recorded? Why is there no technical manual, no schematic, no apprenticeship record, no replication of the technique on any other imperial project? The Mughal Empire built extensively: Lahore Fort, Shalimar Gardens, the Jama Masjid. None of them use this system. The Taj Mahal represents a peak of engineering capability that appears once, works perfectly, and then vanishes from the technical tradition. That is not how engineering knowledge develops. Techniques are refined. Successful methods are copied. Innovations are recorded so they can be taught. The Taj Foundation has none of that. It is isolated. The Archaeological Survey of India is the sole authority controlling access to the substructure. Every request for independent geotechnical investigation has been denied since 1977. The reason given is preservation. Preservation is the management of decay. The Taj Mahal is not decaying. Its foundation is performing beyond modern standards. What is being preserved is not the structure. It is the narrative. The institution that controls the site also controls the data that would answer the question of when the foundation was built, by whom, and with what technology is sealed. Not lost, not disputed. Sealed. This is not an archaeological mystery. It is an administrative perimeter around an engineering problem. The foundation of the Taj Mahal performs at a level the official timeline cannot account for. The system that makes it stable is not documented in the era that supposedly built it. The one survey that measured it in full has been classified for 47 years. 2 construction layers, 1 monument. The upper layer is dated. The lower layer is not. The question is open. The measurement is still there. The official story asks you to believe that Mughal engineers in the 17th century developed a foundation system so advanced that it has shown zero differential settlement in 370 years on a flood-prone riverbank, yet never documented a single specification of that system in any administrative record. The same empire that recorded the cost of every gemstone, every calligrapher's wage, every ounce of lapis lazuli imported from Afghanistan, left no blueprint, no material list, no engineering manual for the most critical structural element of its most famous monument. This is not an oversight. It is a logical contradiction that official history has never addressed. The Taj Mahal sits on the Yamuna River, subject to annual flooding. The soil beneath it is alluvial clay and sand, materials that shift, compress, and settle under load. Every structure built on that riverbank in the same era exhibits the expected settlement cracks, the tilted doorways, the uneven floors. The Taj does not. It stands with millimeter-level symmetry after nearly 4 centuries. The explanation given is ebony wood piles driven deep into the riverbed, interlocking in a grid formation, strengthened by permanent submersion in the water table. This is presented as Mughal ingenuity. It is also a foundation design with no precedent and no successor in the entire Mughal architectural record. No other tomb, no other palace, no other bridge used this method. It appears once, works perfectly, and vanishes from the technical tradition. That is not how engineering evolves. That is how engineering is inherited. Other Mughal tombs on the same stretch of riverbank tell a different story. Humayun's tomb in Delhi, built 80 years earlier, shows visible settlement. Itmad-ud-Dawla's tomb in Agra, built 20 years before the Taj, shows cracking in the lower courses. Akbar's tomb at Sikandra shows differential movement between its core and its cladding. These are the expected behaviors of monumental masonry on unstable ground. The Taj is the anomaly, not in its beauty, but in its physics. It does not behave like the structures around it. It does not behave like the structures built by the same empire in the same geological conditions. It behaves like a structure whose foundation was engineered by a different tradition entirely. The thesis is not speculation. It is the only explanation the measurements support. A civilization with advanced hydroengineering capabilities built the foundation before the Mughal era. The Mughals built the mausoleum on top of it, documented their own work meticulously, and left the earlier foundation undescribed because they did not fully understand it themselves. This is not a new idea. It is the shape the evidence has always had. The Archaeological Survey of India conducted a complete foundation depth survey in 1978. The results were classified. The reason given was sensitivity of findings. Not structural risk, not preservation concern. Sensitivity. That is the language of political management, not engineering caution. 47 years later, no independent geotechnical investigation has been permitted. The institution controlling access to the substructure has maintained this restriction without interruption since 1975. What that survey would show, if released, is the full depth of the ebony pile system, the stratigraphy of the riverbed beneath it, and the material composition of the lowest structural elements. Those three data points would resolve the question of whether the foundation is contemporaneous with the superstructure, or whether it predates it by centuries. The fact that those data points remain sealed is not evidence of a cover-up. It is evidence that the answer to that question has already been determined internally, and has been judged too disruptive to release. There is accidental corroboration. A technical paper published by the Central Building Research Institute in Roorkee in 1983, reviewing moisture-resistant foundation systems in historical Indian architecture, briefly mentions the Taj Mahal's unusual stability under saturated conditions. The paper does not elaborate. It moves on. But the phrase it uses is unusual stability, not expected stability. The word unusual in an engineering context means the behavior does not match the model. The model for a 17th century foundation on alluvial soil predicts settlement. The Taj does not settle. The paper acknowledges this without explaining it. That acknowledgement, buried in a technical journal with limited circulation, confirms the core anomaly without intending to. The mechanism of suppression is not conspiracy. It is identity management. The Taj Mahal is the most recognizable symbol of Mughal India. It appears on currency, on tourist brochures, in every international representation of Indian heritage. Acknowledging that its foundation may predate the Mughal period, that it may have been built by an earlier and more technically advanced civilization, would require rewriting a central chapter of national history. That rewriting has political, cultural, and economic consequences. The suppression is not the work of a shadow organization. It is the ordinary function of institutions tasked with preserving a coherent national narrative. The data is managed because releasing it would destabilize that narrative. The management is bureaucratic, not covert. It operates through classification, access restriction, and selective publication. It does not need to be coordinated. It is the default behavior of any institution whose legitimacy depends on the stability of the story it tells. The single most powerful number in this entire investigation is 0. 0 millimeters of differential settlement. The weight of the structure is known. The Taj Mahal's total mass, including the central dome, the minarets, the platform, and the foundation, is approximately 70,000 tons. The soil properties are known. Alluvial clay and sand have a documented bearing capacity and compressibility under sustained load. The engineering models for that soil type, under that load, over that time span, predict measurable settlement. The measurement is 0. The number itself is the entire argument against the official timeline. It is not a question of interpretation. It is a question of whether the soil beneath the Taj Mahal obeys the same physical laws as soil everywhere else. If it does, then the foundation system is not what the official record describes. If it does not, then we are discussing a localized suspension of material physics, which is not a serious position. The 0 stands. It has been verified by every survey conducted since independence. It is the most thoroughly measured anomaly in Indian architectural history, and it remains unexplained. The cultural layer is not only visible in soil, it is visible in the archives. There is a boundary in the documentation. Below that boundary, there is no engineering data for the foundation. Above it, there is meticulous record-keeping for every element of the superstructure. The marble inlay work is dated to 1632 through 1653. The names of the master craftsmen are recorded. The quarries are identified. The transport logs exist. The payment records exist. The foundation has none of this. It is a void in the administrative record, as clean and sharp as a stratigraphic cut. The stratigraphy is not in the ground. It is in the paper trail that stops at the ground. That is the cultural layer for this structure. It is not a depth. It is a documentary threshold. And it divides two construction realities that the official timeline forces into one. The paradox of precision is this. The more accurately modern instruments measure the Taj Mahal, the more mathematically impossible the official construction story becomes. Laser scanning has confirmed the symmetry of the main dome to within 2 millimeters across, a diameter of over 35 meters. Ground-penetrating radar has mapped the subsurface without excavation and confirmed the regularity of the pile grid. Differential GPS has tracked the position of the structure over decades and recorded no movement. Every new measurement narrows the window in which the official timeline can operate. The precision itself is the witness. Our best instruments, applied to the Taj, do not confirm the Mughal narrative. They testify against it. They show a level of construction control that requires technologies the 17th century did not possess. The tools we use to verify the past are the primary evidence that the past is not what we were told. This two-technology signature is not unique to the Taj Mahal. It appears in monumental structures across the world. Impossibly precise, massive lower sections of stone, fitted without mortar, supporting later, cruder upper sections of brick or smaller masonry. The lower section shows no settlement. The upper section shows expected decay. The official timeline assigns both to the same construction period. The physical evidence assigns them to different eras. You can find this seam in your own city. Look for old buildings where the ground floor is now below street level. Look for windows half buried by the sidewalk. Look for lower courses of stone that are larger, denser, more exactly fitted than the upper courses. That is the boundary. That is the cultural layer. That is not the result of ground rising. That is the result of time, of reconstruction, of a later civilization building on the ruins of an earlier one without recognizing what it was building on. The Taj Mahal is not an isolated artifact. It is a key. It shows you what to look for. Once you see the seam here, you will see it everywhere. The investigation does not end at the Taj. It begins there. Every old structure you walk past becomes a potential witness to the same pattern. The symmetry is too tight. The settlement is too absent. The documentation is too incomplete. And the access is too controlled. Now we close the loop. The question was, where did 20,000 workers sleep in the Indian monsoon? The answer is documented in Mughal administrative records, and it is worse than the foundation mystery. The workers lived in Mumtazabad, a temporary city built 2 kilometers from the construction site. It was not a city. It was a grid of reed huts, bamboo frames, and thatched roofs, constructed seasonally and dismantled or abandoned every year when the monsoon arrived. The monsoon turned the site into inaccessible mud. Construction halted. The workers who could afford to leave did. The workers who could not stayed in the huts as the rains came. 20,000 people in a camp with ditch latrines and no drainage infrastructure. Cholera arrived every year. Dysentery followed. Mughal records, preserved in the archives at Agra and Delhi, show that approximately 3,000 workers died annually from waterborne disease. That is 3,000 deaths per year over 20 years of construction. 60,000 people. Their names do not appear in any record. Their deaths were not mourned in any official document. They were replaced without ceremony, and the construction continued. The records that survive show payment logs, material inventories, and craft guild rosters. They do not show burial lists. The omission was deliberate. Death tolls were erased from progress reports on direct orders from the imperial court. The reasoning was theological and political. The Taj Mahal was a monument to divine love, commissioned by an emperor who claimed spiritual authority. High mortality would suggest the project did not have divine favor. So the deaths were administratively erased. The monument to eternal love was built on an erasure of 60,000 lives. That is not inference. That is what the payment records show when you count the workers at the start of each season and compare them to the workers at the end. The difference is not explained by attrition or contract completion. It is explained by death, and by the replacement labor that arrived without names. The workers did not sleep safely during the monsoon. They died in the mud, in the huts, in the latrines that overflowed into the water supply. And the empire that recorded the weight of every gemstone did not record their names. History is written by those who sign the construction orders, not by those who lay the stone. The ebony wood beneath the Taj was not consulted when the plaques were written. It holds the original specification. The zero settlement is still there. The measurement has been waiting. The investigation is not closed. It is handed to you. The next old building you walk past, look at the lower section. Look at where the stone changes. Look at where the ground has risen or the first floor has sunk. That boundary is not decorative. It is structural. It is temporal. It is the edge of the world we were told existed and the world that actually did. The Taj Mahal is one data point. You are standing on thousands.